Good evening and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And today I continue to explain Pure Mathematics 3 and I'm in topic 7. And in this video I want we look at example 6. I want to explain example 6. And in example 6, that is page 152. And in example 6, we're supposed to show that the integral from pi over 12 to pi over 8 of the sine squared of x with respect to x is given by pi out of 48 plus 1 minus root 2 and that part over 8. That's what we are supposed to show. Step by step. You realize that we do not have a direct integral of sine squared x, or rather we don't know what is the integral of sine squared x. We don't have that prior knowledge. But we recall that sine squared x can be written in many forms. For example, the very obvious one that is going to help us here is when the cosine of 2x is given by 1 minus 2 sine squared x. And from this one, we can just make the sine squared x the subject of the formula. And the reason we have brought up this relationship or trigonometric identity is because we know it is easy to get the integral of the cosine of 2x regardless. But from here, it is important to note that the sine squared of x, the sine squared of x can be given by 1 minus the cos 2x, and this can be seen to be divided by 2. So therefore, if we talk about the sine squared of x to be equals to a half, now this is a half, 1 over 2, a half, opening the brackets, 1 minus the cosine of 2x, then that is easy. And therefore, the moment we have this, we realize that now the whole of this expression is quite integratable. So therefore, we have the integral from pi over 12 to pi over 8 of the sine squared of x with respect to x can be rewritten as the limits do not change, pi over 12 to pi over 8 of now what we have found our sine squared x to be, and we can of course open this bracket so that we have a half minus a half cosine of 2x with respect to x. Having said that, we directly now go to integration, and this is the integration of a half with respect to x is a half x, and the integral of a half cosine 2x, and this is supposed to be negative, we are going to have negative there. The integral of this is that we must be having another function whose gradient is the cosine of 2x. And that function, we now have to use the reverse. Use the reverse of chain rule, something we understood in the previous yesterday's lesson of yesterday's videos, that if we want to integrate the cosine of 2x, we must have had another function whose gradient is cosine 2x, leave alone the half because the half is adjustable. So which function whose derivative is cosine of 2x? We note that that function must have been y is equals to sine 2x, such that now the dy dx of sine 2x becomes something. So let's try it out. The differential dy dx of sine 2x is the cosine of 2x times 2, which is 2, the cosine of 2x. That is as far as the chain rule is concerned. Look, this is what we got after differentiating what we suspected the function would have been. But look, what do we need? We need half cosine 2x. Yet, after differentiating sine 2x, we got 2 cosine 2x. So it's important to note that we got 4 more than what we needed. And if we got 4 times what we needed, not 4 more than, but 4 times what we needed, because if you talk about a half times 4 is going to be 2. So we have 2 cosine 2x, meaning that we got 4 times more than what we needed. So what we do? What we suspected our function would have been now has to be divided by 4. So definitely our y is supposed to be a quarter sine 2x, and that is something that we must remember. And therefore, the integral now, after we realize this is supposed to be the integral of the half cosine 2x, we combine the two and have half x minus a quarter sine 2x, and of course now we have the square bracket because we have integrated. This is pi over 8. Now this is where we are now. It goes without saying. Now we just have to substitute the limits, and once we substitute the limit, the first one becomes, of course, pi over 16, because x is pi over 8. We have pi over 16 minus a quarter the sine of 2x. 2x is 2 pi over 8, which is going to be pi over 4. Pi over 4. This one now we have to subtract. When we substitute with the lower limit, which is pi over 24, minus a quarter sine of 2x when x is pi over 12, minus the sine of pi over 6. And it goes without saying, of course, now we are talking of pi over 4 is 45, and of course degrees, and pi over 6 is 30. Let us just talk about those angles here. This is 1, this is 1, this is 90, this is pi over 4. Of course, this is root 2. What is the sine of 45? 1 opposite of a hypotenuse. So the sine of pi over 4 is 1 over root 2. Of course, if you rationalize this one, you're going to have you're going to have root 2 over 2. You're going to have root 2 over 2. So we are going to have now, if we take the whole of this, pi out of 16 minus a quarter multiplied by root 2 over 2. The whole of that now minus pi over 24 minus a quarter. What is sine 30? We can just have it here. This is an equilateral triangle. This is 2, this is 1, this is root 3, and this is 30. So opposite of hypotenuse, a half, and that is just like that. So at the end of the day, if you want to open these brackets, you're going to have pi over 16 minus root 2 over 8 minus pi over 24 plus 1 over 8. Now collecting the like terms, we have we need now to open the brackets. Pi over 16 minus root 2 over 8 minus pi over 24 plus, because of these two negatives, 1 over 8. Collecting the like terms, now we have pi over 16 minus pi over 24. Of course, if you settle this one separately, the LCM is going to be 48, and 3 pi minus 2 pi, which is pi out of 48. That is that. And again, if you have 1 over 8 minus root 2 over 8, the LCM is just 8, and you're going to have 1 minus root 2. That is the other part. That is now the other part of the when you collect the like terms. So if you combine the two, bringing them together, then we are having pi out of 48, of course, plus 1 minus root 2 over 8. And all this is what we were supposed to show. When you combine the two, bring them together, we are having pi out of 48 plus 1 minus root 2 over 8. And this is just what we're supposed to show, and hence shown. Again, it's a long question, yes, but step by step, you must, or you should get home. So again, go to my YouTube channel, subscribe, and let us work together. All right?